So Tim Condon, I'm with Delta Ag, I'm an advisor, so this all ties in very nicely. I work out of Harden, up in the hilltops, and I had a fair bit to do with the Burra farm as well, so all very connected. So my task was to talk about commercialising probes, how we do that, and the quick rundown will be on the Goanna Gofield probe, just a quick snapshot of that. Goanna Ag was a subsidiary company of Delta, and then to house all our tech stuff, and then eventually it's been spun off and it's just its own company now doing its own thing. And I'll just quickly run through that Gofield, which we've already heard a bit about from his. And then Hussat and Delta formed an alliance to get pterosons in the ground. Paul's the amazing scientist who does these things, and we're the sort of the front end of it, if you like, who interacts with growers and gets to use them. So quickly, the Gofield thing, it's an irrigation scheduling solution for cotton. So that's obviously a cotton crop. It's only for cotton, really. They're developing corn next, but really broadacre applications outside of cotton aren't really happening. Field sensors, the soil moisture probe and the canopy temperature sensor. So they're the two key components, and you heard a bit about this amazing bit of gear here. That's a whole day's seminar in itself, how that works and what it does. It's an amazing bit of tech. So that measures the stress of the crop. You heard about that before. Combines with weather data, crop growth stage, and a bit of analytics that are very well researched and very powerful. So it delivers irrigation scheduling solutions to cotton growers. So that's what it's all about. And soil moisture probes are part of the agronomy of this package. What do we need a soil moisture probe as part of this for? Well, primarily, the main thing it's used for initially is to develop a robust root system of the crop. You've all seen these by depth, by sensor outputs, so the lines are slightly declining each time. There's not much water going in. So this is the early stage of the crop, August, October. So we're trying to get the crop to develop a resilient root system so it can support it later on when it really needs the water. And then you saw that one before about the sawtooth of the PAW when we get to the business end of the season, the irrigation scheduling, and we're trying to avoid that red bar there. If you remember down here, we had the canopy temperature sensor as well. From his graph, I probably should have included it here, but so you've got two things to look at. You've got the soil water probe, clean available water, and you've also got the temperature, the canopy temperature sensor. So you use both those bits of data, particularly the canopy temperature sensor, at this time of year to avoid that happening, because that's costing 2% of yield a day. So that you don't want that to happen. So 2 hours before that red line starts, you want the water coming in the paddock, so to get the efficiencies. So identifying exactly how much water the crop needs when it needs it. So significant adoption, about 200,000 hectares of cotton, 40% of the crop last year used this technology or this tech. Water, energy and labour efficiencies of greater than 10%, increasing yield per megalitre 12 to 15%. So these are good outcomes, and it's got a well-researched and proven ROI of 10 times. So pretty significant use of tech for this. Now I want to switch now to the pteroson probe. So you heard us talk about, or people talk about Paul Hutchinson's here, who was a CSIRO researcher back in the year 2000, and he developed this probe because this is on the long-term trial site over at another site of Harden in my backyard, and we're trying to look at how can we measure the amount of water that goes out the bottom of the profile. Because remember, we came out of the 90s very, very wet, and our catchment, the Jugong catchment, put the second highest salt load into the Murrumbidgee River. So there was government concern about what are these farmers doing. They're putting all this salt into the system. They must stop this. So we're looking at possible land use regulation to stop it. So we want to understand what goes out the bottom of a crop. And of course, what happened after the year 2000? Millennium drought. No water's gone out the bottom since, pretty much. But this bit of tech, the pteroson probe, we thought, hang on, this is a smart bit of gear. We can use this in dry land cropping. We were talking about growing wheat and canola primarily. So you've heard about what it is, dielectric sensors, 8 of them put them in a plastic tube. We've since developed it so it's now wireless, so you don't have to dig a cable hole from the probe to the base station, which we see is a really good thing, because you're not running water to the probe or you're not messing with the soil. You just bang, drill a hole with a specialist bit of gear, put the probe in, and then it talks to the base station, which is 30 metres away, and that ships your data up to the cloud, up to your server, and away you go. So that's the guts of it. We spent a bit of time doing this location. That's what we call a topographic wetness index. Similar to what sort of happens is so many layers available. Which one do you use? But we just try and find where the water is. We're trying to find a uniform spot to put a probe. This is a grower who's got 3 or 4 probes already. They've got 4 on their other farms. They bought a new farm. They wanted to say, where am I going to put my probes? I want to probe on this farm. So we're trying to find out where to do it. So these are sort of layers, soil colour. We use yield data, obviously, where we've got it. And then we find, okay, we're going to put the probe there because it's 30 metres off a fence there. There's no trees near there. It's a pretty uniform piece of soil type. It's the median colour of the farm, so we're likely to get our best bang for our buck there. Output. What does this thing put out? It's a simple fuel gauge. We're not really hung up on what the actual number of millimetres of water is over here. But is the bucket we've got, is it full or is it empty or is it half empty? Is it about to go empty? Is it about to fill up? What's going on? That's how we use the information. So I grabbed a probe with 2 years of data from 19 to 20 because at the moment they're just full. It's just telling us they're full. So I went back and got this one here. So you see coming out of 18 drought. This is a long season grazing dual purpose wheat. So grazed along, got to here, things are going downhill. We only got 300 mils of rain for the year. So cumulative rainfall events, PAW. So end of that, and then we hit the 2020 season and things really improved. And we've got a lot of water here in August that we can make decisions on. So that's what I wanted to talk about. Where is that water in the profile? We believe that knowing what's in the profile to that depth is really valuable. Some work by Kierkegaard back in the mid-2000s was showing us that you can get 60 millimetres of grain per millimetre of water if it's coming from there when you can't get it from anywhere else. So if you've got stored water, we work on 10 to 20 millimetres per kilograms per millimetre, but when you've got this stored water in the spring when you need it, it's really valuable. And they've got data to show us that 50 to 60 kilograms of grain per millimetre. So we want to know what's down here. So in this instance, the wheat came to here, we got to August, we're looking at the crops, this is not very good. We've got those lambs over there, well, let's put those lambs in that crop, let's cut that one for silage, we might help us make those, guide those sort of decisions for our drought management strategy decisions. Come 2020, and we've got a stack of water here, and we came off the back of 19 pretty gun-shy about inputs. This is a spring canola crop, and we said, okay, let's go for it. Let's put pedal to the metal here, we've got an opportunity. And that went 2.9 tonne of canola in 2020. So you've heard lots of talk about 3 tonne canola crops in 21, and everyone's very excited for the first time. But we got that in 2020, a year ahead of the game, because we didn't hold back. And so that's how we would use the fuel gauge in this situation. And so you can see the differences there. The total water was 115, but there's 80 odd mils here, and I think over here there's 150. So you can see, knowing where that water is, we think is benefit to that depth. So that's how we use them. And the canopy temperature sensing analytics, there is none of that. What do? We use Cliff's common sense, we use our eyes, and we go and have a look about, see what's going on. We use a bit of NDVI imagery. We go and have a look at the crop. What's the crop telling us? We can't do it any other way. A commercial and broad acre, is it losing tillers? Are the bottom leaves going yellow? What's going on? Is everything happy? So we use that sort of information, stick a probe in the ground and apply some brain power and make some decisions. So that's as simple as that. So I went through, and I come back to this. That's how we made all those decisions in those 2 years using this bit of data from a point on the farm. Here's another one we picked up on a hostile subsoil out on the Grawlin Plain. Barley, which can tolerate acidity and salinity more than anything else. 2017, we put the probe in. We were really happy days with this grower, used the water up. 2018, put the canola in, and the canola started running out of puff here. And we're sort of wondering what's going on. This is dying way faster than it should be. We're in a drought, but it's still dying way faster than it should be. And it just wasn't using any water below 60 or 70 centimetres. So Cliff, we went and dug a hole, had a look, hostile salt layer there. So we don't grow canola in that paddock anymore. So another little example of how we can use the data. This is not just mainstream crop stuff. Last summer, you all know, we came out the back of 21, wet harvest, bog headers, headaches. We're all really tired, got to January, and this was a wheat crop here, and massive self-sown wheat crop. Should we go and rush in and spray it out? What should we do? Look, things are looking pretty good. We know that it's using about 2 mils a day. Let's just watch what it does for a bit. Let's put the sheep in there and use it because I'm too tired to go and spray it, and delay our spraying decision, which is what we did. So because we had the confidence that we weren't tapping into our big bucket here, so we're happy to let that go longer. We sprayed one spray late and then got the sheep in there and hammered it to cycle the nutrients back in, because nutrients and water got to be kept. And we're fairly convinced that if you can graze the material with it, put it through a sheep, you'll actually get a lot of it back. You don't lose that nutrient as much. So that's how we made that decision there. This winter, Paul's really excited about this because he did all that work in the 2000s to look at deep drainage. Profile's full, but look at these rain events here. We've had 150 mils there. The profile was full. The profile's still full. Where did that water go? It's gone out the bottom. A little bit's run off, but most of it's gone out the bottom. So that's gone somewhere else in the landscape, which that's what the probe was originally designed to measure, not so much for all the other stuff we use it for. But that's it happened. So the key differences: go field, cotton irrigation scheduling. The science and tech. It's advanced. It's integrated. Significant adoption with a proven ROI. The Terrasont, how we use those in dry lands. It's a simple fuel gauge. It's pretty slow adoption. Most growers, some growers got one or two, but invariably they get one, then they get another one, then they want another one, then they want another one. So obviously they're getting some value out of them. So that's it's gaining traction. And look, there are some big farms that run on business models that are probably more stringent than some of the corporates, and they really want to know what their numbers are. I mean, they're making growing marketing decisions, for example. They want to know what's going on. So they're sort of attracted to them as well. Lots of add-ons coming up now. The soil water app, we can do an API straight into that now, so that you can use that app on your phone to look at stuff if you want to really start playing with modelling. And what else is going on? Arrays. I think this is another exciting opportunity for soil moisture sensors. Grower groups, the Hard and Murrumbidgee Land Care Group, which I'm in as well. We've got an 11 probe array, and it's on the back of Paul's work with some funding that we got from Jaramas. So Paul's landscape probes, we've got them on 3 different sides of the landscape, so we can see what goes on with the water across as a group. So we've got that data available publicly. Holbrook, you've got 4 down there, with a part of your network. Research groups, the Cyro Bars one you talked about. Farming Systems Trials have got them in. Sydney Uni at Narrabri have got a bunch in. Dale Gray's Fast Break, he uses, how he uses arrays of probes to just get out there what's going on with soil moisture water. And I think the future, the potential, there's going to be a heap of money come because climate change funding is going to just start rolling out the door. So, and using some of that funding effectively to do things for farmers, like the Farm Forecaster Service, like the Tablelands Farming Systems and Monero Farming Systems. They've tapped into this sort of stuff to deliver forecasting for pasture growth for graziers. So that is a bit of a quick snapshot about how we're using probes commercially.